Hello and welcome to week 6 in geometry. At this time, please make sure you've got your math notebook out. We're going to start using our math notebook with a couple warm-up problems, and then you're going to continue to use your math notebook as you take notes as you watch this recording. So we are working in our probability unit, and the two warm-up questions are probability-based questions. So let's imagine we've got a bag full of marbles. And in that bag, there are 2 red marbles, there are 3 green marbles, there are 3 orange and 2 purple marbles. So based on that information, the first question you are going to answer is, what is the probability of choosing a green marble? And then, is this an example of experimental or theoretical probability? So go ahead and click pause, answer these 2 questions on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so the first question we were asked was to find the probability of choosing a green marble. So just a reminder of the notation that we've been using for probability. So if I were going to write this in probability notation, I would use a capital P, and then I'm just going to put green. I don't have to put green marble. If you want to, you can, but what is the probability? This means what's the probability of finding or choosing a green marble? So to find that probability, how many green marbles can we choose from? Well, there's 3 in our bag, so we could choose 3, and then what is the total number of marbles we're choosing from, which is the total number of outcomes that we can have? Well, there was 10 marbles, so it would be 3 out of 10. So remember, we can write probability as a fraction. We could leave it as 3/10. Or we can write it as a decimal, and if we did that, that would just be 0.3. Or we can write it as a percentage, move our decimal 2 places to the right and get 30%. So just a reminder that we can write probability as fraction, decimal, or percentage, and that's a 0.3. That kind of got weird looking there. All right, and then is that an example of experimental or theoretical? Well, remember, experimental is based on a number of trials or experiments, and there's none of that. We didn't collect any data here. We didn't choose a marble, write it down, choose another one, write it down. So this is purely based on what we expect to happen. So this is an example of theoretical probability. All right, so we get our minds back to thinking about what we learned last week with probability and being introduced to probability. So this week we're going to continue our exploration of probability, and in Unit 6, Session 2, we're going to look at independent and dependent events, and then in Session 3, we're going to look at two-way tables. And before I move on, just a quick note about due dates this week. So we do have next Monday off, President's Day weekend. So no school on Monday. So what I did was, instead of making your assignments due on a non-school day, I made them due on that Friday before the weekend. However, that is just suggested this week since it's a funny week with losing that Monday. You can still work over the weekend, and I'm not going to take off late points. So I'll start grading on Tuesday morning. As long as you've got your work in before I start grading, I'm not going to take off late points. So don't stress about that changed due date. It's more just, I guess we could look at it as a suggested due date this week. All right, so let's move into learning about independent and dependent events. So before we do, let's talk about what these vocab terms mean. So dependent events are when one event affects the probability of another event. So the events are dependent on one another. One event will affect the probability of another event. A lot of times you'll see examples of dependent events when you reach into a bag of marbles and you pull out a marble and then you do not put that marble back and you choose another one. So that would be those events. That second event depends on the first event, because if we were looking at our warm-up, we started with 10 marbles. Well, if we pull one marble out and we hold on to it, and then we're asking about the probability of another event, we're only choosing from 9 marbles now. So that second event affects the first. Another example would be picking a card from a deck and not putting it back. So not replacing something is a good example of where we can get dependent events. Whereas independent events occur when one event has no impact or influence on another event. An example would be rolling a dice and then picking a card from a deck of cards. Neither of these events affect the other. Rolling a dice and picking a card are two totally different things. So these would be independent events. One event has no impact or influence on the other event. So we're going to look at how we go about finding the probability of each of these types of events. So let's start with independent events, where one event does not affect the outcome of another event. So we already talked about what independent events are. So how do we find the probability of independent events? So if we have event A and event B, so we'll talk about event A and event B, and they are both independent events, meaning neither event has an outcome, affects the outcome of the other event, then the probability of both events occurring, so let's say we want to find the probability of both event A and B occurring, we will do that by finding the product. Product, remember, means when we multiply two things together, of the probabilities of each individual event. So what we're going to do, if we want to find the probability of event A and B occurring, and they are both independent events, so we want to find the probability of A and B, what we're going to do is we're going to find the probability of just event A, and we're going to multiply that times the probability of event B occurring. So let's take a look at an example. It always makes a lot more sense when we start actually applying what we're learning to an actual example. So down at the bottom, we've got an example. We've got a drawer containing 3 red paper clips, 4 green paper clips, and 5 blue paper clips. So 3 red, 4 green, 5 blue. One paper clip is taken from the drawer and then replaced. So we're putting it back. We're not changing the number of total outcomes. Another paper clip is taken from that same drawer. So we want to find the probability that the first paper clip is red and the second paper clip is blue. All right, so let's write that in proper probability notation. So we want to find the probability of getting a red and a blue paper clip. So in order to do that, we're first going to find the probability of just choosing a red one. And we're going to multiply that times the probability of choosing a blue one. So what is, I'm going to continue down here, the probability of choosing a red paper clip? How many red paper clips are there? Looks like there's 3 out of the total number. So we've got 3 plus 4 is 7 plus 5. 3 plus 4 is 7 plus 5. I'll make sure I had right there with the number. So that is a total of 12, right? If we add up all of our paper clips, we have a total of 12 to choose from. And then we're going to multiply that times the probability of blue. How many blue are there? There's 5. And since we didn't do, we replaced our first choice, we still have a total of 12 paper clips to choose from. So the probability of red and blue, we're going to take 3/12 times 5/12. And we just multiply those two probabilities together. 3 times 5 is 15. 12 times 12 is 144. I'm pretty sure I can take out a factor there, right? Divide, can I? Or 122. I meant to say 122 down there. Oops. That's what, 15 over 122. 12 times 12 times 12 is 144. I did have that correct. So can we take anything out of, can we divide anything out? Can we simplify that fraction? I think we can divide each by a 3, right? Divide each by a 3. When we take 15 divided by 3, we get 5. And when we take 144 and divide that by 3, we get 48. So we can reduce that fraction. Another thing we could have done is just reduce this 3/12 before we multiplied. I know 3/12 simplifies to 1/4, and then it would have been easier to just get that 5/48. So if you can simplify before, sometimes that's the better way to go about doing it. And that would be our final probability, would be 5/48. We'll go ahead and leave this as a fraction. Remember, we could put it as a decimal and a percentage, but let's just leave that as a fraction. So that's how we find the probability of independent events. It's pretty straightforward. Find the probability of each event occurring on their own and then multiply those two together. Let's go to dependent events. I want to go to dependent events. So dependent events, and how do we find the probability of dependent events? Remember, that happens when we've got an event that is affected by another event. The events are then said to be dependent. So if we're talking about events A and B again, and they are dependent events, and we want to find the probability of both events occurring, then the probability of both events occurring is going to be the product of the probability of the first event and the probability of the second event occurring once the first event has occurred. So now we've got some special notation. So let's look down here. Focus your attention down here. Our notation is going to look a little different when we find the probability of dependent events versus what we did for finding the probability of independent events. So we're still dealing with events A and B. So to find the probability of both events occurring, if they're dependent, is first we're going to find the probability of event A, written just like this, probability, or capital P, parentheses A. Now we want to multiply that times the probability of event B once A has occurred, because A has affected B. So we write the event of B occurring once A has occurred like this. Look down here. Capital P, and then parentheses B with this line A. And what that means is right here, event B once A has occurred. So make sure we understand how to correctly write the notation and that you understand this. So go ahead and write this down in your math notebook right now, that if you were to see capital P and then in parentheses B with the line A, that means event B once A has occurred. And then you multiply those two together. So let's go ahead and apply this to an example, because we know things always make a lot more sense once we see it in an example. So we've got this same drawer that we just found the independent probability of. Same drawer. We've got 3 red paper clips, 4 green, and 5 blue paper clips. One paper clip is taken out of the drawer and then it's not replaced. And then we reach in and choose another paper clip. So we want to find the probability that the first paper clip is red and the second paper clip is blue. So how do we do that? Let's go ahead and write down our notation here. So we want to find the probability of choosing red and blue. So because we are not replacing a second paper clip, the second event is going to be affected by the first event. So we would write this as the probability of choosing red, and then we're going to multiply it times the probability of choosing blue once we've chosen red, or after we've chosen that red. All right, so what is the probability of choosing red? Well, we already did this, right? Red is 3 out of 12. And then what is the probability of choosing blue? Well, blue, how many blue are there? There's 5, but how many are we choosing from now? Because we were holding on to that first marble. So now there's only 11 to choose from. So see how that's a little different in this example. And then we're gonna multiply together. Again, if I want to reduce and say that I've really got 1 out of 4, I'm reducing. I know I can divide a 3 out of that and to get 1 out of 4 and multiply it times 5 out of 11. And what do I get? 1 times 5 is 5, 4 times 11 is 44. So 5 out of 44 is our probability here with our dependent event. So again, make sure that you are noting the difference between independent and dependent events. So let's summarize what we've talked about so far. So I'm going to go on the next slide, so if you need more time, go ahead and click pause. So summary, probability in a nutshell is a number of ways something can happen divided by the total number of outcomes. That's the most generic way we can summarize what probability is. But now when we start talking about more specific types of probability, we can say that dependent events, such as when you take something out of a bag and hold on to it, you're not replacing it. Dependent events are affected by the previous events. Whereas independent events are not affected by the previous events. And we can calculate the probability of 2 or more independent events by multiplying. Same with dependent events. We find the probability of 2 or more events by multiplying those together. All right, so in session 3, you're going on to look at two-way tables. Two-way tables. So we can use two-way tables to deal with 2 different variables. And whenever we're talking about 2 variables, we can refer to that as bivariate data. Bi, you get that prefix bi meaning 2. So 2 types of variables that we are referring to. And we can use two-way tables to examine the relationships between 2 variables. And we can use that table then to analyze survey data. So here's an example down below of a two-way table. We are comparing 2 sets of variables or bivariate data. So if we were to ask a group of people and divide that group of people into males and females, those would be our 2 categories, whether they would prefer to have an SUV over a sports car, and then for each category of males and females record the answers. So if we were to look at this two-way table, we could see that 5 males preferred a SUV and 7 preferred a sports car, where with females, 9 would prefer to have a SUV and 4 would prefer to have a sports car. So if we were looking at this table, could you answer this question? If you could have a new vehicle, oh, that's what the question asked, sorry. So what I was going to ask is, can you determine the total number of people surveyed? Can we determine the total number of people surveyed from looking at this this table? Well, sure. Let's first find all the totals. We can find the total number of people who'd want an SUV. 5 plus 9 is 14. And then the total number that would want a sports car would be 11. Add those up and we get 25. So there's a total of 25 people. We could have added our rows up too and gotten 12 for males and 13 for females, which adds up to a total of 25. So either way we do it, whether we're adding the columns up together and then that total, or the rows and that total, we come to the grand total of 25 people who were surveyed. I'm going to go on to the next slide where we're going to look at this table a little bit more in depth and talk about different types of frequencies we can look at. So when we give in two-way tables, one thing that we can calculate is the joint relative frequencies. And the joint relative frequencies are the values in each category divided by the total number of values. So remember, the total number of values we just found is 25. Whoops, no, actually not. ignore that for a second. It was 25. I was correct with saying that. I thought for some reason it wasn't a total of 25, but we did. On the previous slide, we found the total number of values to be 25, right? So that means the total number of people that were surveyed, we found that there's 25 people surveyed on the previous slide when we added all our numbers here. So the total number of values is used to find the joint relative frequency. So let's go ahead and find the joint relative frequency in this table that we've been looking at. So the joint relative frequencies are going to be the values in each category. So 5, 9, 7, 4, those are the values in each category. And we're going to divide the value in each category by the total number of values. And in this case, it was 25. The survey was asked of 25 people. So if we take 5 and divide it by 25, what do we get? We want to write joint relative frequencies as a decimal. So 5 divided by 25, we get 0.2. So there's one of our first joint relative frequencies, going to be 0.2. That might be a little hard to see in orange. Let's change to blue. So it'd be 0.2. Then to find the joint relative frequency of females choosing an SUV, we're going to take 9 and divide it by 25. I'm going to grab my calculator, type in 9 divided by 25 to find that decimal, and I get 0.36. I'm going to continue this pattern. The joint relative frequency of males choosing a sports car would be 7 out of 25. Do the division there, and we get 0.28. And the last one, 4 divided by 25, which represents females choosing a sports car. 4 divided by 25 is 0.16. So these are, since I changed color, we're going to change this, blue. These are our joint relative frequencies in blue. All those numbers in blue. Now, the marginal relative frequencies, we find those, let's do that in purple, the marginal relative frequencies is another way that we can look at our table and analyze it. And we find these by adding all of our joint frequencies together in each column and row. So if we were to find the marginal relative frequency of SUVs, we're going to add 0.2 plus 0.36. We add the joint relative frequencies in each column and row. So if we're to find for SUVs, we add 0.2 plus 0.36 and we get a total of 0.56 or 56%. Again, writing that as a decimal and writing it in purple. For a sports car, we would add 0.28 plus 0.16 and I get 0.44. And now I'm going to do the totals for my rows. So the marginal relative frequency of males is 0.2 plus 0.28. We get 0.48. And do the same thing for the marginal relative frequency for females, adding 0.36 plus 0.16, and we get 0.52. Now, a pattern that will always occur when you add your marginal relative frequency totals together. So when I add this column together and this row in the column, my total here should always add up to 1. It should always add up to 1. So when I add this total, my row, if I'm doing my row, 0.56 plus 0.44, what do I get? I get 1. When I add the row totals together, 0.48 plus 0.52, I get a total of 1. If you do not get a total of 1 over here in this corner, you have done something wrong. You've done some math wrong. The total should always be 1. When we add up all of our marginal relative frequencies, when we add up the rows and the column, we should always get 1. So remember that, and that will help you to see if you've made any mistakes. And then we can use the data that we've just calculated to answer these two questions below. So it says, if a person is a male, what is the probability that they will choose a SUV. So if they are a male, so we're only dealing with this row here because it asks if the person is a male. So we're only looking at the male row. What is the probability that they will choose a SUV? Right here, it would be 0.2. We have a 0.2% or a 20%. So 0.2 or 20%. If we're looking at percentages, if we have these in percentages, they would always add up to 100%. Just throw that in there. And then the last question I want us to answer before we stop this recording, if a person chooses a sports car, what is a probability that they are female? So now we're only looking at the sports car column. Sports car column. If a person chooses a sports car, what is the probability that they are female? Well, it's right here, 0.16 or 16%. So that's how we use two-way tables. Is a lot of times you'll be answering questions about the two-way tables, and it'll be based on a certain row or column. Just like we did with these examples. So I'm going to go on to the next slide. So if you need more time, go ahead and click pause. And we are to the key phrase assignment. Let me put that up. So in probability, there's a lot of notation that is used to show different types of probability that we're looking for. And it's really important that we understand what the notation means. I went over what this notation means in the weekly recording. So I want you to tell me, what does P parentheses B line A, what does that mean? What does that mean? What does that notation mean? What are we looking for? What type of probability? So answer that question for the key phrase question. You'll get your points for watching this recording. Have a great rest of your week, and as always, let me know if you have any questions or you need help with anything.